Okay, so now we're going to start taking some notes on what if there are two patterns that we're looking at when we're looking at representations of growth? What if we're looking at the growth of two patterns? And how do we find the solutions for that? So, in order to go through this, I want to just remind you um, some things that we have talked about in the past that feel a little bit more important all of a sudden. So I'm going to label these notes finding the solution, for multiple patterns. And then we need to go back to like what it means to be a solution. So if we go back to remember when we had equations with single variables. So like 2x plus 3 equals 15 or something like that. So in an equation with a single variable, the solution is the number that makes the equation true. The solution is the number or the value for x, right? Or for whatever variable it is that makes the equation, that makes the equation true. It's supposed to say true. So for example, I'll give you an example here. So for example, let's go through, let's look at this equation here, right? We have an equation x plus 3 equals 7. Okay, so in this, right, there's only one equation. There's only one value for x that could make this a true statement, right? There's a lot of numbers. I could put any number down for x, but they wouldn't all be true. Like if I said 10 plus 3, if x was 10, 10 plus 3 does not equal 7. So it can't be 10, right? So there's only one equation, or there is only one number one value for x that can work. So like if we were to do, so for example, 2 plus 3 is not, right, is not 7. So 2, or so x is not 2. And 3 plus 3, 3 plus 3 is not 7. So x is not 3, because that wouldn't make sense. 4 plus 3 is 7. So x has to be 3, or has to be 4. Right? And if we were to keep going, we wouldn't run into any other values. So like if we, if we went 5 or bigger, right? 5 plus 3, now we're back to is not 7. So x is not 5. And if we keep going, we'll keep hitting higher numbers, right? So right? This is how, so the equation is the one value. Sometimes there's more than one solution, but the equation is the value that makes the statement true. Okay, so in an equation, let's change the color here. I'm gonna stick with this navy blue for my drawing color. So in an equation with two variables, it actually like gives it a little bit more flexibility to have multiple answers. So in an equation with two variables, there are lots of possible solutions. Because there are lots of ways to make this statement true. Lots of ways to make a true math statement. I don't know why I made statement 2 words here. I'm going to try to fix that. Just bring it over there. Looks like I got to bring this part over too. Let's bring that over. Apparently it's very difficult for me to do that, but let's do that too. So for example, if I was to change, so x plus 3 equals 7, there's only one possible solution. But what if I change that example and I make it have two variables? So in this one, for example, let's change it to x plus 3 equals y. So now there's two variables, right? I'm not constrained by everything has to equal 7, right? X plus 3 doesn't have to equal 7 this time. X plus 3 could equal anything. So now, if x equals 2, right, then y is 5, because 2 plus 3 equals 5. But x doesn't have to be 2, right? When x equals 3, y is 6, because 3 plus 3 equals 6. And when x equals 4, y is 7. Because 4 plus 3 equals 7, right? And we can keep doing this. When x equals 5, y is 8, because 5 plus 3 equals 8. So, right, there are lots of different ways to show this. So, I'm going to put all my thens in here. Let's see. Oops. Equals 8. Just finish these sentences up, right? Just make them right. Okay, so so each solution would be listed then as a pair, right? So we write this as a number pair. So each solution is listed as a pair of numbers. X is always first. y is always second. So our examples would be, right, if we were to do x and y, that would look like this. We would have when x is 2, y is 5. When x is 3, y is 6. When x is 4, y is 7. When x is 5, y is 8, right? When x is 79, x would be 82, right? It's just whatever the first number is. When x is 1,000, y is 1,003. Whatever it is, we're just adding 3 to it, and then we're putting down that value for y. So that's how we would write our solutions for any of the infinite solutions that we have.